All right, welcome. Let's just dive right in, shall we? Today, we're taking an epic geographical journey to decode the mighty Ganga River System. And look, here's the best part. We are absolutely not going to rely on rote memorization for this explainer. Memorizing a bunch of random facts usually just leads to forgetting them the second you're under pressure anyway, right? Instead, we're going to figure out exactly why these rivers behave the way they do, the actual science behind their paths, and how we can perfectly map this vast, massive network using a little bit of logic and some incredibly brilliant visual tricks. To do this, here's our roadmap for the day. 1. Origins in the Panch Prayag. 2. Journey through the plains. 3. Decoding the tributary network. 4. Anomalies and human engineering. And finally, 5. The Delta and Ganga dolphin. All right, part 1, Origins and the Panch Prayag. This is where it all begins. Okay, first things first, we've got to bust a massive myth. That fast-moving stream gushing straight out of the Gomukh Glacier is actually not the Ganga yet. That is the Bhagirathi River. Instead, we need to shift our focus over to the Alaknanda River. I want you to imagine the Alaknanda as this ancient, totally massive natural superhighway flowing down from the Sadopant Glacier. Because the mountain slopes up there are just incredibly steep, other rivers, both big and small, literally come crashing into this Alaknanda highway at terrifying speeds. And they're not just bringing water. We're talking glacial ice, massive boulders, tons of heavy sediment. When these violent rivers collide in those deep mountain valleys, the confluence is called a prayag. Now, along the Alaknanda's epic journey, there are 5 major violent collisions. We call these the Panch Prayag. Trying to remember their exact north to south order? Yeah, that can be a total nightmare for students. But consider this brilliant Hindi mnemonic. Vishnu, Kinund, Kitkanme, Rudra, or Dev Base. I know. It sounds like some ancient poetry, but it's actually a complete geographic master key. Let's decode it. Let's step through this progression from north to south. First up, Vishnu stands for Vishnu Prayag. That's where the Dalaganga hits the Alaknanda. Next, Nand is Nand Prayag, joined by the very similarly named Nandakini River. Kan literally means ear, which represents Karna Prayag, where the Pindar River merges in. Moving down, Rudra is Rudra Prayag, where the Mandakini joins from the Kedarnath side. And finally, boom! Dev stands for Devprayag. This is the grand finale. Right here, the Bhagirathi River, remember, the one from Gomukh, crashes into the Alaknanda. It is only after this massive final collision at Devprayag that the combined waters officially earn the legendary name Ganga. Moving right along to Section 2, Journey Through the Plains, the Haridwar Transformation. So after Devprayag, our newly named Ganga cuts its way through the mountains until it hits the city of Haridwar. And right here, the entire character of the river completely transforms. It escapes those steep, narrow mountain gorges and suddenly spills out into the flat plains. The slope drops to practically zero, and this fast, super aggressive mountain river instantly turns into a wide, slow-moving giant. This sweeping giant now starts an absolutely massive journey across the Indian subcontinent. Do you know the exact length of the Ganga? It's an impressive 2,525 kilometers. 25. It's the longest river in India, and honestly, the sheer scale of the land and the millions of people it impacts along this path is just staggering. So where exactly does this 2,525-kilometer lifeline actually go? Well, it flows from Uttarakhand into Uttar Pradesh, then Bihar, and finally West Bengal. But wait. Look closely at that 4th bullet point, Jharkhand. This right here is a classic examiner's trap. A lot of people just assume the Ganga totally skips Jharkhand, but it actually grazes the border of Jharkhand's Sahibganj district. So it geographically touches 5 states, not 4. Definitely keep that one in your back pocket. And hey, for anyone specifically studying Uttar Pradesh geography, the river's path is defined by 2 super crucial borders. Here's a really quick trick for you. The Ganga entered the plains of UP at Bijnor, and it exits the state into Bihar at Balia. Entry, Bijnor. Exit, Balia. Both conveniently start with the letter B. It's just a simple visual anchor to help lock that map right into your memory. All right, Section 3, Decoding the Tributary Network. Let's look at the left and right banks. You see, a 2,525-kilometer river absolutely doesn't survive all on its own. It's fed by this sprawling, crazy web of tributaries, joining from the left bank, which are mostly your Himalayan rivers, and the right bank. Let's tackle those left bank Himalayan tributaries first, because examiners just love asking for their exact west to east sequence. So here's our second powerful mnemonic, Aramu Gomdi Gagra Gandak Ki Kosi Me Mahan Hai. Once again, kind of an odd-sounding Hindi phrase, I know, but trust me, it's an absolute lifesaver. Check out how perfectly this maps out geographically from west to east. Remu gives us Ramganga. Gomti is directly the Gomti River. Gagra is the Gagra River. Gandak and Kosi are just directly named, and Mahan stands for the Mahananda River all the way in the east. Literally, just like that, you've flawlessly organized 6 major Himalayan tributaries in their exact, correct spatial order. Pretty cool, right? But there's a rebel in the group. One of these left bank rivers behaves very, very strangely. The Kosi River. It's infamous as the sorrow of Bihar. Why? Well, it basically acts like a massively clogged pipe. You see, it rushes down from these highly unstable parts of the Nepal Himalayas, carrying completely insane amounts of heavy rocks and sediment. When it hits the flat plains of Bihar, the water suddenly slows way down. All that heavy sediment just drops straight to the bottom, essentially choking the river's own channel. So with its normal path blocked and water still aggressively pushing from behind, the river violently breaks its banks. It floods completely new farms and villages where literally no river existed the day before. Which brings us to Section 4, Anomalies and Human Engineering, defying nature itself. So, let's shift our gaze over to the right bank tributaries coming from the peninsular plateau, like the Yamuna. But we also really need to look at how humans have tried to engineer this massive water system. The right bank is totally full of mind-bending geographic anomalies. Take the Son River, for example. The general slope of the peninsular plateau tilts east or west, right? Yet the Son River originates in the Amarkantak Plateau in central India and flows directly north to join the Ganga near Patna. How is that even possible? How can a river seemingly flow uphill, totally fighting the natural gravitational slope of the land? Well, the answer is actually hidden deep underground. Millions of years ago, tectonic plate collisions created these massive fractures in the earth, known as rift valleys or fault lines. The Son River is actually trapped inside one of these deep tectonic fault lines. This massive fracture fundamentally altered the local slope, literally forcing the river to flow north, cutting right through the plateau. It's a spectacular geographical exception, which of course is exactly why exam setters love to ask you about it. And speaking of traps, let's talk a bit about human engineering. If you're ever asked which river India's highest dam, the towering Tehri Dam, is built upon, your immediate instinct is probably going to be to say the Ganga. But actually, scratch that, that is wrong. Think back to our very first section. The Tehri Dam is located super high up in the mountains, long before that final Devprayag confluence. So technically and geographically speaking, it's actually built on the Bhagirathi River, not the Ganga. It's a subtle distinction, but an absolutely crucial one. Further downstream in West Bengal, right before the border with Bangladesh, sits another total engineering marvel, the Farakka Barrage. When the river finally reaches Bengal, it splits into 2. One branch, the Hooghly, flows down through Calcutta. But the intensely flat delta terrain means the Hooghly is constantly filling up with all that Himalayan silt we talked about earlier. If we just left it alone, the river would become way too shallow for any cargo ships, completely killing the historic Calcutta port. The Farakka Barrage solves this problem by artificially diverting massive amounts of water from the main Ganga. It acts like a giant mechanical flush system, blasting that sediment straight out of the Hooghly and into the sea, saving the port's economy in the process. Finally, Section 5, the Delta and Ganga Dolphin, the ecological climax. So we've reached the climax of this entire journey. Choking on billions of tons of sediment, the river finally loses its pushing power. It splinters. The Hooghly flows south through India, while the main branch flows east into Bangladesh, where they call it the Padma. Together with the Brahmaputra, they form literally the largest delta in the world, the Sundarbans. Because of the monumental scale of this ecosystem, we're talking about supporting hundreds of millions of humans, vast mangrove forests, and incredible wildlife. The Indian government officially declared the Ganga as India's national river back in 2008. It's not just a religious symbol, it's a completely irreplaceable lifeline for biodiversity. And right at the very heart of this biodiversity is the river's ecological guardian, the Ganga dolphin. Crowned as India's national aquatic animal, this incredible creature is completely blind. No way, right? It actually hunts in those murky, muddy waters using ultrasound waves, basically echolocation. But the most crucial fact about this dolphin, the thing you really need to remember, is that it requires absolutely 100% pure, unpolluted fresh water to survive. Because it's so incredibly sensitive, scientists classify the Ganga dolphin as the ultimate bioindicator. What does that mean? Well, it means if you see this dolphin happily swimming around and hunting in a stretch of the river, you don't even need to take a water sample back to a lab. Its mere presence is living, breathing proof that the water is clean and the entire ecosystem is thriving. But, this brings us to a pretty chilling reality. If the dolphin is a bioindicator, what does its absence mean? If we pollute the waters so much that this blind ultrasound hunting guardian literally disappears from an area, it means the pollution has crossed the point of no return. It really begs a thought-provoking question. If the bioindicator dolphin completely vanishes, is that stretch of the mighty Ganga already technically dead? It's a profound reminder that understanding the geography of this incredible river system is only the very first step in actually protecting it. Thank you so much for joining me on this explainer, and keep exploring.